Today, we're going to discuss proving triangles congruent. Let's start with today's bell ringer, a proof to show that two triangles are congruent. And remember, in order to prove that two triangles are congruent, we need to show that all 6 corresponding parts are congruent. So all 3 sides and all 3 sets of angles need to be proved congruent. So let's look at our first given, that C is the midpoint of EB. A midpoint divides a segment into 2 congruent segments, so E is cutting EB into 2 parts. So I tick mark my segment into 2 congruent segments. And I look, EC is congruent to CB. That probably goes here. So, why did I know EC was congruent to CB? It was given that C is the midpoint. So, since C is the midpoint of EB, I can say that EC is congruent to CB, that a midpoint divides a segment into 2 congruent segments. I'm going to do something similar for the next given, C is the midpoint of AD. So far, I've shown that 2 sets of sides are congruent. Why are the other set of sides congruent? It was given. So looking at the diagram, segment AB is congruent to segment ED. We have now shown that all 3 corresponding sides are congruent. Our next job is to look for the angles. Let's see if we can figure out which angles are the vertical angles that we're focusing on. And I think I see them. Angle ACB is congruent to angle DCE. Is there another set of angles that we can show are congruent? The angles that were given. Angle B is congruent to angle E. Then our third set of angles are congruent because of the third angle theorem. If 2 angles of a triangle are congruent to 2 other angles of a triangle, then that third set has to be congruent. So our proof is complete with angle A congruent to angle D. We have shown that all 3 corresponding sides are congruent and all 3 corresponding angles are congruent. Let's look at the next part of the problem. Here, we are going to review the important vocabulary of included. So, name the included angle between XY and XZ. That would be angle X. Name the not included angles between YZ and XZ. Angle Z is included, so that means angle X and angle Y are the non-included angles. Name the included side between angle Y and angle Z. That would be segment YZ. Name the non-included sides between angle X and angle Y. XY is the included side, so the non-included sides would be YZ and XZ. Now let's take a look at our objectives. So our objectives today will be to discover what triangle congruence postulates work for proving triangles, and proving triangles are congruent using those postulates. Basically what we have here are shortcuts. We are going to discuss how to not have such a large proof showing all 3 sides and all 3 angles are congruent. In addition, to use these postulates correctly, we need to be able to name included sides, angles, and the non-included sides and angles, and we need to figure out which are the corresponding sides and angles of the two congruent triangles. So let's look at our potential shortcuts. In our first example, we need to identify the three sets of corresponding parts. In this case, we're dealing with all three sides. So let's list all three sets of sides. So the first combination of corresponding parts are the sides, if all three sides are congruent. We abbreviate that with side, 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 and we abbreviate even further by writing 3 S's for side, side, side. But when you say it out loud, you say side, side, side. So, is it possible that if you know all 3 sets of sides are congruent, that is enough to prove that the two triangles are congruent without knowing anything about the angles? Let's look at the next example. Write down all 3 sets of corresponding parts. In this example, we know that 2 sides are congruent to the 2 other sides, and their included angles. We would abbreviate this shortcut side, angle, side. Is this combination of corresponding parts enough to say that we know the whole 2 triangles are congruent? So after you list this 3 pairs of corresponding parts, what do you think we will call this shortcut? No bad words. We call it side, side, angle. Now, is this combination of 3 parts enough to show that the 2 triangles are congruent? But before we move on, I want to focus on the difference between side, angle, side and side, side, angle. This is where the word included becomes very important. In side, angle, side, the angle is included by the 2 sides. In side, side, angle, it is the non-included angle that is for this particular combination. So make sure you are careful. Just because you see 2 sides and an angle doesn't mean it's side, angle, side. It could be one or the other. Let's look at the bottom row. List all the sets of corresponding sides. In this case, we're looking at 2 angles and the included side. This description is this description is angle, side, angle. So if you know this combination of congruent parts, are these 3 pieces of information enough to show that the 2 triangles are entirely congruent? For this 5th example, write down the corresponding parts that are congruent. For this example, it is the 2 angles that are congruent, but the non-included side. So this abbreviation is angle, angle, side. As we look at these 2 examples on the bottom, just because there are 2 angles and a side doesn't mean it works for everything. These are 2 different situations. The first one has the side included between the angles. The second one does not have the side included between the angles. So it's important that we make note of the difference of these 2 pictures. For our 6th combination, list the corresponding parts that are congruent. This abbreviation is angle, angle, angle. Just knowing that all 3 sets of angles are congruent, is that enough to show that the 2 triangles are entirely congruent? So here are our 6 possible shortcuts. instead of showing that all 6 corresponding parts are congruent, we can cut that work in half and just show that 3 sets of corresponding parts are congruent. But which 3? In a bit, you'll go to Google Classroom and open up the GeoGebra link, where you're going to see all 6 possibilities. What you need to know is that only triangles that are shaded are congruent. So our goal is to figure out which triangles will be congruent no matter what. So now I'm going to preview going to GeoGebra. After you go to Google Classroom and click on the link, you will come to GeoGebra. You will click View Book. And here you will see that there are 6 possibilities, the same ones that we talked about earlier. Let's look at the first one. Here we have an example of side, side, side. I know this because all 3 sides are marked. It will be my job to try to move these triangles in any possible way so that the triangles are not shaded. And it does not look like that's possible. So I am going to imagine that no matter what, if you are given all 3 sides are congruent to all 3 sides of a different triangle, those triangles are going to be congruent. So looking at my worksheet, I see that these 3 sets of sides are congruent to each other. This shortcut is a side, side, side. We tried to change these triangles in a way so that the triangles would not be congruent, but we just couldn't do it. So the triangles were always congruent. Looking back at our GeoGebra, I can just click the arrow to look at problem number 2. Here we have a different set of corresponding parts that are congruent. These triangles are not congruent because they are not shaded. If I could move these around so that it's possible, but I'm just not seeing how that's going to work. So I'll continue with my worksheet with Congruent Triangle Exploration 2. And then it will be your job to finish the rest of the worksheet using GeoGebra. When you're finished, please make sure you complete the exit slip and get the assignment.